national anthem, the pledge, and the future anthem.
Arise, O compatriots, Nigeria's call obey, to serve our fatherland with love and strength and faith. The labor of our heroes past shall never be in vain, to serve with heart and might, one nation bound in freedom, peace and unity.
Nigerian National Pledge. I pledge to Nigeria, my country, to be faithful, loyal, and honest, to serve Nigeria with all my strength, to defend our unity and uphold our honor and glory. So help me God. Nigeria, good people, great nation.
Future anthem.
Ever winning, never leaving, never peaceful, advancing the course of technology. Land of nation, landmark. For national progress, academic excellence is our tradition. Technology for self-reliance. Self-reliance, yes. Self-reliance, yes. Promoting of unity, not autism. Championing the cause of technology. The shining example. The pride of Nigeria. With the blessings on our side, we shall go places. For self-reliance.
Thank you very much. Let us all be seated. This day, we are all welcome to the Federal University of Technology, Akure, the nation's best university of technology. We are having the 165th inaugural lecture to be delivered by Professor Olabode Olatubosun, titled Machine Learning, Pattern Machine and Classification Experience with Technology to Solve Human Problems. This day again, we have in our midst the leaders of our academic community under the chairmanship of the Vice Chancellor, Professor Adenike Temidayo Oladiji, Fellow Academy of Science. You are welcome to this program, ma'am. To be supported by other principal officers, we have the Deputy Vice Chancellor Academic, Professor T.T. Amos. You are welcome to this program, sir. The Deputy Vice Chancellor Development, Professor S.S. Oluyamon. You are equally welcome to this program. The Registrar and the Secretary to the Council, Mr. Charles Olusegun Adeleye. You are equally welcome, sir. We have the Chancellor of our Exchequer, Mr. Julius Adeshoba. Please, you are welcome to this program as well. We have the University Librarian, Dr. Robert Akinade Awoyemi. You are welcome, sir. The inaugural lecturer, Professor Olabode Olatubosun. You are welcome. By this side of the divide, we have the deans of our various schools of study. We have Professor Mrs. Oluwatoyin Faramade Oludansi, Dean, School of Agric and Agricultural Technology. You're welcome. We have Professor Victor Koliko Ukwanya, Dean, School of Basic Medical Sciences. You are welcome. We equally have the Dean, School of Engineering and Engineering Technology, Professor Peter Olukayode. You are welcome, sir. We have the Dean, School of Environmental Technology, Professor Isaac Olani Aje. You are welcome, sir. We have the Dean, School of Computing, the School of Professor Olabode, that is Professor Boniface Olukayode Aleshe. You are welcome, sir. By this side, we have other deans of our schools. We have the Chairman Committee of Deans and the Dean of School of Mines and School of Health and Mineral Sciences, Professor Y.A.B. Anifowoshe. You are welcome, sir. We have the Dean, School of Life Sciences, Professor Michael Olufemi Ashamo. You are welcome, sir. We have the Dean of School of Physical Sciences, Professor Adebola. You are welcome, sir. Professor is ably, the Dean, School of Logistics and Innovation Technology, is ably represented by Professor Olowokere. You are welcome, sir. And the Dean of Student Affairs, the Capacity Dean, Professor David Olarewaju. Okay, a round of applause for him. You are welcome, sir. To this end, I would like to bring to the podium for the delivery of our address the Vice Chancellor, Professor Adenike Timidayo Oladiji. A round of applause for the Vice Chancellor. Thank you very much.
Thank you. Thank you. The Deputy Vice Chancellors, Academic and Development, Registrar, and other principal officers, my lords, spiritual and temporal, top government functionaries here present, the inaugural lecturer of today, Professor Olabode Olatubosun, deans, directors, and heads of department, particularly the Dean of the School of Computing, distinguished members of Senate and congregation, eminent scholars and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. It is with delight and a profound sense of honor that I welcome you to the 165th inaugural lecture of the Federal University of Technology, Akure, Futa. I cordially welcome our spiritual and traditional leaders, top government functionaries, captains of industries, friends of the university, and the entire staff and students of the university. With great delight, I welcome the immediate and extended family members, friends, and well-wishers of the inaugural lecturer. The 165th inaugural lecture is a proof of our steadfast commitment to dissemination of knowledge and pursuit of academic growth. This evening's lecture puts the spotlight on the scholarly work of Professor Olabode Olatubosun and his contribution through his field of study and work to humanity. May I, at this juncture, request the inaugural lecturer to please rise while I present his citation. Olabode Olatubosun was born on the 27th March 1967 in Ilutitun, Ondo State. He had his elementary education at African Bethel School, Ikorodu, Lagos State, between 1975 and 1978. Thereafter, he proceeded to Moribodo College, Ilutitun, for his secondary education, which he completed in 1985. He gained admission to the Federal University of Technology, Akure, in 1986, where he bagged BTech Industrial Mathematics, MTech Computer Science, PhD Computer Science, and MTech Statistics in 1991, 1999, 2005, and 2015, respectively. He later proceeded to Ekiti State University, Ado-Ekiti, in 2018, where he obtained MSc degree in Peace and Security Studies in 2021. Professor Olatubosun has published over 73 articles in both local and international peer-reviewed journals, and he is a reviewer for academic and professional journals, such as the International Journal of Computer Science and Applications, International Scientific Press, British Journal of Mathematics and Computer Science for Science Domain International United Kingdom, and Issues in Business Management and Economics. Professor Olatubosun has supervised over 30 masters and 18 PhD students to completion. He has served as external and internal examiner at many undergraduate and postgraduate examinations, and he has participated in many local and international conferences. Professor Olabode Olatubosun belongs to Computer Professionals Council of Nigeria. He has served the university in several capacities, such as being the chairman, School of Computing Curriculum Development Committee from 2022 to date. He is member, Curriculum Review Committee from May 2015 also to date. Postgraduate coordinator between 2011 and August 2013. He was PGD Computer Science Coordinator between 2006 and 2009. And Professor Olatubosun is happily married, and the union is blessed with promising children. Machine learning is a branch of computer science and artificial intelligence that is concerned with building computer systems to imitate the way humans learn through the use of data and algorithms, and gradually improving to accuracy. This enables computers to learn from and make predictions or intelligent decisions based on data, leading to advancements in various fields and industries. Distinguished ladies and gentlemen, to present the 165th inaugural lecture of the university, titled Machine Learning, Pattern Matching and Classification Experience with Technology to Solve Human Problems. Please join me to welcome Professor Olabode Olatubosun as he makes his presentation.
The Vice Chancellor, Deputy Vice Chancellor, Academics, Deputy Vice Chancellor, Development, the Registrar, other principal officers of the university, Provost, Deans and Directors, Professors and members of Senate, my Lord Spiritual and Temporal, distinguished guests and friends of the university, gentlemen of the press, distinguished ladies and gentlemen, great Futarians. All glory, honor, and adoration be to Almighty God, who has made it possible for me for me to attain this height in life and has granted me the unique opportunity to deliver the 165 inaugural lecture of this esteemed institution. University of Technology, Akure, this is the 165 inaugural lecture titled Machine Learning, Pattern Matching and Classification Experience with Technology to Solve Human Problems, which marks the 6th in the field of computing and the 3rd in the School of Computing and the 1st in the Department of Information Systems within the School of Computing. Information is power, as is often said. One of the most significant needs of information is for decision making. In today's fast-paced world, decision must be made quickly and efficiently. However, having access to accurate and timely, reliable information can help individuals, government, organizations make informed decisions that can positively impact the lives and properties and environments, including the business. The Bible is quite accurate when it says in Daniel 12:4 that, "But ye, Daniel, shut up the word and seal the book until the time of the end. Many shall run to and fro, and knowledge shall be increased." Undoubtedly, we live in a world where knowledge is exponentially and astronomically increased. Estimates include that in 1900, knowledge doubles every 100 years. In 1945, knowledge doubles every 25 years. People at that time were already impressed with the rapid advancement in knowledge. Recently, knowledge doubles every 12 hours. When the Bible says knowledge shall increase, it surely does increase, and the growth is just beyond our widest imagination. The topic of today emanated from my experience in life. From when I was in primary school, I discovered that God has been so gracious to me that He endowed me with a special gift of creativity and visual pattern recognition of objects from not so clearly revealing images in the space. My case was like an artist who can imagine things and bring them to reality by crafts. It was when I came back to FUTA for postgraduate studies that I realized that it is possible to reveal the hidden treasures from the invisible. The Vice Chancellor, I'm deeply honored and profoundly grateful to stand before you today, acknowledge the privilege bestowed upon me to address this esteemed gathering. With a heart filled with gratitude to God, I embark on this journey into the captivating world of machine learning, where the fusion of intellect and innovation unlock the transformative capabilities in pattern matching and classification. This inaugural lecture enables to illuminate the path of understanding, exploring the profound experiences that this technology offers and its roles in addressing intricate human challenges. Introduction. Machine learning, with its capability is a pattern matching and classification, is a powerful tool for solving a wide range of problems, human problems across various domains. In our quest for knowledge and progress, we find ourselves at the crossroads of technology and human ingenuity. Machine learning stands as a beacon, a testimony to our ability to push the boundaries of what is possible. It's a dynamic field that empowers machines not only to process information, but also to learn, adapt, and contribute to the resolution of complex problems that have long challenged our intellects. What about pattern matching? Pattern matching refers to the process of identifying and recognizing specific patterns or structure within data. In the context of computer science and data analytics, pattern matching involves searching for particular sequence of elements, symbols, or features within a data set. This concept is widely used in various fields, including programming itself, data analysis, image processing, natural language processing, and many more. In essence, pattern matching is a versatile concept with application in diverse fields, enabling the extraction of meaningful information from complex data sets and aiding in decision-making process across various domains. Machine learning classification is a type of supervised learning where the algorithm is trained on a labeled data set to learn the mapping between input features and corresponding output labels. The primary goals of classification algorithm is to predict the categorical class label for new unseen instances based on the pattern learned during training. Typical of classification algorithm includes that of binary and multi-class classification. However, common classification algorithm includes the logistic regression, the decision tree, random forest, support vector machine, the k-near neighborhood, naive Bayes, and so on and so forth. Machine learning has significantly influenced and transformed various technological sectors, providing innovative solutions to complex problems. Some key areas where machine learning has made significant impact includes the natural language processing, the computer vision, healthcare, finance, e-commerce, autonomous systems, cybersecurity, marketing, advertising, and many more. Consequently, this application illustrates how machine learning technology have become integral to all advancement in various sectors, enhancing efficiency, accuracy, and decision-making process across industries. The ongoing development in machine learning, we know that continue to open up new possibilities for solving complex problems and driving technological innovation. As the topic of today, machine learning has proven to be transformative technology with the ability to solve a wide range of human problems through pattern matching and classification. By leveraging sophisticated algorithms and vast data sets, machine learning systems learn from experience, make them adept at recognizing patterns and automating decision process. The subject domains of my contribution to learning. The Vice Chancellor, my contribution to knowledge encapsulates a holistic approach in advancing the field of self-computing, artificial intelligence, machine learning, deep learning, biometrics, and information systems. We look at some of these key points. Artificial intelligence, which is commonly referred to as AI, is a process of impacting data, information, and human intelligence to machine. The main goal of artificial intelligence is to develop a self-reliant machine that can think and act like human. These machines can mimic human behaviors and perform tasks by learning and problem solving. Most of the AI systems simulate natural intelligence to solve complex problems. Artificial intelligence can be used to solve real-world problems by implementing the following processes and many more: machine learning, deep learning, natural language processing, robotics, expert systems, and physiology. These three things, AI, machine learning, and deep learning, sometimes are used interchangeably, but they do not quite refer to the same thing. Figure 1 will help us to understand the fundamental differences between AI, machine learning, and deep learning. As for the artificial neural network, the neural network is a network trained to perform complex tasks. The network consists of a number of process elements that we refer to as neuron. The neuron is the network which either accepts input from outside world or from the output of other neurons in the network. The output from all the neurons propagates through the network and reaches a final output layer. The process of the network depends actually on the weight of the interconnections connecting neurons in the network. Figure 2 explains this concept. Let's look at multi-layer perceptron. The most successful model in the context of pattern recognition is the feed-forward neural network, also known as multi-layer perceptron. The multi-layer perceptrons is really a misnomer because the model consists multi-layers of logistic regression model with continuous nonlinearities rather than multiple perceptrons with discontinuous nonlinearities. The linear model for regression and classification respectively are based on linear combination of fixed nonlinear base function phi j of x and takes the form of equation 5.1, where the function f is a nonlinear activation function in the case of classification and is the identity in the case of regression. The goal is to extend this model by making the basic function phi j depends on parameter and then allow these parameters to adjust along the coefficients wj during training. This leads to the basic neural network model, which can be described as a series of functional transformations. First, we construct m linear combination of the input variables x1 to xd in the form of equation 5.2, where j takes value from 1 to m, and the subsequent one indicates the corresponding parameters are in the first layer of the network. We shall refer to this parameter WJI as the weights and the parameter J0 as the biases. The quantity alpha J's are known as activation. Each of them is then transformed using a differentiable nonlinear activation function H to give equation 5.3. This quantity corresponds to the output of the basic function in 5.2 that in the constant of neural network are called the hidden layers or the hidden units. The nonlinear function H are generally chosen to be sigmoid function, such as the logistic sigmoid and the time function. Following 5.3, these values are again linearly combined to give output units activation 5.4, where K takes value from 1 to K, and K is the total number of output. This transformation corresponds to the second layer of the network, and again, the WKO are the bias parameter. Finally, the output units activation are transformed using an appropriate activation function to give a set of network output YK. The choice of activation actually depends or is determined by the nature of the data and the assumed distribution of target variable. Thus, for standard regression problem, the activation function is the identity so that YK is equal to SK. Similarly, for multiple binary classification problem, each output unit activation is transformed using a logistic sigmoid function so that YK is equal to sigma of a function SK, where sigma alpha is equal to 1 over 1 plus exponential minus alpha. But for multi-class problem, the max function, the softmax activation function of more forms is used. We combine these various stages to give a overall network function that for sigma output unit activation function, which takes the form of equation 5.7, where the set of all weights and the bias parameter has been grouped together into a vector W. Thus, the neural network model is simply a nonlinear function from a set of input variable xi to a set of output variable yk, controlled by the vector W of adjustable parameter. This function can be represented in the form of a network diagram as shown in figure 3. The process of evaluating 5.7 can then be interpreted as a forward propagation of information through network. Furthermore, the biases parameter in equation 5.2 can be absorbed into the set of weight parameters by defining an additional input variable x0, whose value is clamped at x0 equals to 1, so that equation 5.2 will now take the form of equation 5.8. We can similarly absorb the second layer biases into second layer weights, so that overall network function becomes equation 5.9. Let's look at some of our contributions in the area of artificial neural network. In Olabode 2007, we applied the multi-layer perceptron radial basis function, generalized regression neural network, general feed-forward neural network, and time lag recurrent network to simulate the forecasting of a stock market price. The data set used for this training of the artificial neural network model were those that may contribute to the closing price of stock in consideration. These are the numbers of these quantity traded, value shares, opening price. The output variables of interest was the closing price of the stock in consideration. The data was collected over a period of 12 months on a daily basis. The neural network model developed required 3 sets of data sets, which includes the 75% of data set for training, 20% for testing, with remaining 5% for validation. Table 1 presents the comparison of the different models or network performance on the training data set from which the best model was selected. We actually contributed again in the area of medicine. We developed a neural network in the classification of cerebrovascular accident attack, commonly referred to as stroke. In Olabode and Olabode 2012, we developed a neural network for classification of cerebrovascular accident attack stroke in patients. We adopted the multi-layer perceptron artificial neural network with back propagation model. The data for this research was collected from the Federal Medical Center, Owo, Nigeria. and contains a record of patients suffering from cerebrovascular accident attack. Data were collected from 100 records, including 60 males and 40 females of patients. The model classifier was trained using the backward propagation algorithm with flexible sigmoid activation function at 4 hidden layers with 16 input nodes representing stroke onset symptoms at the input layer, 10 nodes at each of the hidden layers, and 1 node at the output layer representing the type of stroke or type of attack. The learning rate was set between 0.1 and 0.9. The network was successfully trained at 150 epochs with accuracy of 96.5%. Let's look at machine learning, which is a subset of artificial intelligence that focuses on developing algorithms and models that enables computers to learn and make decisions based on data. Machine learning enables computers to automatically learn patterns, rules, and representation from data without requiring explicit programming from specific tasks. The 3 categories of machine learning include the supervised, the unsupervised, and the reinforcement learning. The most widely used machine learning methods are the supervised learning methods. The supervised learning experience includes the object classification of videos, price of product prediction, face recognition over images, the medical diagnosis of systems from patients, all as applying the functional approximation problems, where the training data takes the form of a collection of XY pair, and the goal is to produce a prediction Y asterisk in response to Y query, response to S queries. The X may be classical vector, or they may be more complex objects such as documents, images, DNA, sequences, or graphs. Much progress has been made by focusing on the simple binary classification problem in which Y takes on one of 2 values, for example, COVID or not COVID. But there has also been abundant research in problems such as multi-class classification, where Y takes on one of K labels. We also have the multi-label classification, where Y is labeled simultaneously by several of the K labels. We also have the ranking problems, where Y provides a partial order of some sorts. And then we have the general structure prediction problems, where Y is the combinatorial objects of such a graph, whose components may be required to satisfy some set of constraints. Some of our work includes the machine learning in the diagnosis of head and neck cancer. In our study by Olabode et al. 2020, the head and neck cancer are seen as the 6 most common cancers of the more than 100 cancer types worldwide. Patients at the primary health centers usually experience misdiagnosis and sometimes suffer delays in referral. To solve this problem, Olabode et al. 2020 developed a machine learning diagnostics model to enhance prompt and accurate diagnosis of head and neck cancer. The data set for this study was collected from 3 hospitals, including the University of Medical Sciences, Ondo, the Federal Medical Center, Owo, and Obafemi Awolowo University Hospital. The obtained data from the pathology and ear, nose, and throat, head and neck cancer department was harmonized and used to establish the model. The data set consists of 1,473 instances, 18 features, and 4 classes. The data set was divided into training, test, and validation data set in the ratio of 70, 20, and 10. The 2 supervised learning algorithms we use includes the decision trees, K-near neighborhood, and the decision trees and the K-near neighborhood. The results shows that the accuracy of decision tree was 91.40%, and the KNN has accuracy of 88.24% respectively. In another dimension, Olabode 2022 opined that the conventional diagnosis of head and neck cancer is based on the histological evaluation of tissue sections from biopsies of surgical resection. In addition to clinical and radiological examination, this method can be time-consuming and are prone to errors in observation or variation in interpretation, which can result in inconsistencies in cancer grading and prognostication. Consequently, this can cause delays and inaccuracies of diagnosis, which may have significant implications for patients' management and survival. In the study of Olabode et al. 2022, information gain, chi-square decision trees, naive Bayes were adopted to probe if we could achieve a better diagnosis and classification at a faster rate. This method involves several key components such as the data collection, which involves gathering relevant data on head and neck cancer, data preparation, which involves cleaning and preprocessing of the collected data to handle missing data, outliers, inconsistency. The feature selection method is a filter-based method which involves selecting features based on statistical measurements such as the correlation, information gain, and chi-square. The experimental result shows that the accuracy of decision trees was 93.21. Naive Bayes had an accuracy of 94.12%. The naive Bayes actually have a higher precision recall and FR score than the decision tree. And based on the performance metrics, naive Bayes perform better than the decision tree. Let's look at machine learning in the prediction of diabetes mellitus. The primary goals of the study of Olabode et al. In 2016 is to address the signal health challenges of diabetes by exploring the impact of relevant features on the performance of classifier systems. The PIMA-Indian data set was utilized. It consists of 460 records of female patients of at least 21-year-old PIMA-Indian heritage. The principal component analysis was applied to identify the optimal subsets of features that can both necessarily and sufficiently be used for classification. The Kernel support vector machine algorithm with variable basis function was used for classification. The performance accuracy of the machine classifier was evaluated using accuracy precision recall F1 score to measure the effectiveness of the models in predicting diabetes. The results of the performance evaluation is presented in table 2. In another study of Olabode in 2015, we focused on diabetic diagnosis using the maximum covariance weighted resilience backpropagation procedure. The method was divided into 3 phases. The first phase involved considering a large number of candidates' hidden units and initializing the weight with a random value. The hidden unit is then selected among the candidates using the maximum covariance. The weights feeding the output units are calculated using a linear regression method. And after the maximum covariance initialization, the network is trained with a resilience backward propagation algorithm, which is an adaptive trading algorithm. The activation function used in this hidden unit is a hyperbolic tangent function. The data set used for the study consists of information from 142 diabetes patients. 10 baseline variables were considered, including the age, sex, body mass index, average blood pressure, and 6 blood serum measurements. The response variable of interest is the quantitative measure of disease progression 1 year after baseline. The model was trained, tested, and validated using a specified methodology. The result of the study indicates that the algorithm is efficient in diagnosing diabetic patients, and this achieved a reported accuracy of 96.45%. We also did some work in the classification of fish. Fish recognition is a very complex and difficult task despite its commercial and agricultural usefulness. Some of the challenges facing the accurate and reliable fish recognition includes the distortion, noise, segmentation, error, overlapping, and occlusion. In Inaugural on Olabode 2015, we developed a machine learning model for the classification of fish species. Among the techniques we use include the support vector machine, the K-near neighborhood, the K-means clustering, the neural network. The study was based on shape features and image texture dataset obtained from selected fish species through the collaboration between Fishery Department of FUTA and Adekunle Ajayi University. 6 features, namely the body length, the caudal fin length, dorsal fin length, pelvic length, the pectoral length, were extracted. The fish texture database comprises of extracted textures from the 2 species. Each of the fish image was in JPEG format of 20 by 20 pixels at 256 grade level per pixels. The result is as presented in the table 4. Deep learning, we also did some research in deep learning. Deep learning, which is a branch of machine learning that is based on artificial neural network, it has the capability of learning complex pattern and relationship within pattern. In deep learning, we do not need to explicitly program everything. It has become increasingly popular in recent years due to the advances in processing powers and availability of large data sets to embark on machine learning research work. The key characteristics of deep learning is the use of deep neural network, which has multiple layers of interconnected nodes. This network can learn complex representations of data by discovering hierarchical patterns and features in the data. Deep learning algorithms can automatically learn and improve from data without the need for manual feature engineering. So deep learning has achieved signal processing in various fields, including the image recognition, natural language processing, speech recognition, and even recommendation systems. Some of the popular deep learning architectures include the convolutional neural network, recurrent neural network, deep belief network, and many more, because the thing keeps evolving on a daily basis. Training deep neural network typically requires a large amount of data and computational resources. However, the availability of cloud computing and the development of a specialized hardware such as GPU, the graphic processing unit, has made it easier to train deep learning network. We have applied deep learning in some areas like healthcare. In our study, Akiriwa et al., 3 separate models based on assembled of convolutional neural network, CNN, for the analysis and classification of histopathological image of breast tissue was presented. The assembled model seeks to extend the performance of the existing CNN by combining AlexNet, VGGNet, and ResNet using majority voting, averaging, and stack ensemble rule. Furthermore, a model for classification of breast histopathological images was developed and codified as SADUNet model. This model was developed with fewer convolutional neural network layers to reduce computational costs in terms of memory and improve computational time. All the models were trained with the histopathological images data collected from the Federal Teaching Hospital, Ido, with approved ethical consideration. Figure 20 shows the architecture of the proposed or assembled of the breast histopathological images classification. While figure 21 is the schematic representation of SADUNet model. The comparative analysis performed showed that the developed model performs as well as those found in literature, judging by the accuracy achieved. The assembled method also performed better in terms of sensitivity and predictability than the individual-based model. This is showed in the high predictions and recall value obtained by the assembled model. During the testing, the base model generated the following accuracies. The AlexNet generated accuracy of 92.91%. The VGE16 gave an accuracy of 96.28%. The ResNet, 99.25%. When tested with the FTHI breast histopathological data set, the averaging assembled has accuracy of 99.47%, while the majority voting assembled has an accuracy of 99.30%. The stacking assemble model has an accuracy of 97.86%. The SADUNet model achieved an accuracy of 75.89%. We also have another research in health, deep learning using transfer learning in healthcare. In Olabode et al. 2023, we adopted the transfer learning model to diagnose COVID-19 with medical chest X-ray images extracted from database of National Hospital, Abuja. We also collected from Kaggle and GitHub repository. The aim is to provide the medical practitioner with an alternative way of diagnosing COVID-19 through image classification model. We identified suitable transfer learning model through a comparative study of some implemented CNN model. We optimize and utilize the selected VGG16, DensNet 121, DensNet 69, model net V2, and exception exception resonance model for the challenging COVID datasets. Implementing recognition and classification. The performance of the transfer learning model was reported in an attempt to standardize the appropriate model that could be adjudged best for COVID-19 diagnosis. We reported the performance of the transfer learning model by We reported the performance of the transfer learning model to standardize the appropriate model that could be adjudged best for COVID-19 diagnosis. Finding indicated that VGG16 performed excellently well in terms of accuracy, but in terms of computational time, the mobile net V2 computational time is the best. The VGG16 CNN model performs at considerable level of COVID-19 detection and classification with accuracy of 96.5%, precision at 96%, recall at 96%, and F1 score at 96%. The highest accuracy of this deep learning diagnostic model can significantly improve the swiftness and accuracy of COVID-19 diagnosis in our local hospitals. We also work in the area of biometrics, which is the science of establishing the identity of individual based on physical, chemical, or behavioral attributes of person. Biometric system uses a variety of physical or behavioral characteristics, including the fingerprint, the face, the geometry, iris, retina, signature, gait, palm print, voice, and etc. We also conduct some research in this area. We start with biometric performance identification on 2D wavelength transform and chi-square model. In Adeni Year Tour 2015, we presented our research work on the 2D wavelength transform and chi-square model for iris, feature extraction, and recognition. Circular Hopf transform was used for the segmentation of the iris images. The system localizes the circular iris and pubis regions and removes the occlusion earlids and the eyelashes. The extracted iris region is normalized using the Dogman rubber sheet model into a regular block with constant dimension to account for image inconsistencies. The face data from the 2D wavelength transform data extracted from the biometric, forming the biometric templates. The chi-square distance is employed for classification of iris templates and recognition. The performance of the iris is stated below in terms of computational speed, robustness, and performance. We also tried to do some work in the area of signature identification system with principal component analysis and steady-forward thinning algorithm. In Olabode Tour 2015, we designed and implemented an algorithm for handwriting signature identification. The signature identification system consists of signature acquisition, preprocessing, feature extraction, and matching stages. Signature acquisition can be either online or offline, or sometimes both. The gray image is converted to binary, which is black and white. The image is then thinned using steady-forward thinning algorithm. The image is cropped to read the image of unnecessary white noise. For feature extraction, principal component analysis was used. Feature extracted from each signature were stored as a template. After feature extraction, the distance between the signature templates are computed using the Manhattan distance. If the distance exceeds a certain threshold, the test signature is rejected. Otherwise, it is accepted. Conclusion. The Vice Chancellor. I wish to draw my conclusion based on what I have been able to achieve in the past few years of my research in the area of artificial intelligence, machine learning, deep learning, soft computing, and biometrics. Machine learning has actually addressed the question of how to build computer that improve automatically through experience. It's one of today's most rapidly growing technical fields, lying at the intersection of computer science and statistics, and at the core of artificial intelligence and data science. The progress experience in machine learning has been driven both by the development of new learning algorithms and theories and by the oncoming explosion in the availability of online data and low cost of computational resources. Deep network methods are being actively pursued in a variety of additional applications for natural language translation to collaborative filtering. The internal layers of deep learning can be viewed as a representation of input data, while much of the practical success in deep learning has come from supervised learning method for discovering such representation, while effort has also been made to develop deep learning algorithms to discover useful representations of the input without the need for labeled training data. Deep learning has been applied in medicine and agri, biometrics, security, and so on and so forth. Many authors of biometric systems have developed and deployed many algorithms and applications to solve problems with biometric identification and authentication, yet with challenges. These challenges were highlighted in our publication and solutions were profiled to the shortcomings. Recommendation. The university management should capitalize on research output from School of Computing to align with the current trends in digital and intelligence service delivery, ultimately contributing to economic growth through entrepreneurship. 2, certainly, achieving the goals of creating 4 million digital jobs per year as proposed by the government requires is strategic and deliberate effort from governments. By embracing artificial intelligence, machine learning, it can play a crucial role in this transformation. Governments can implement comprehensive skill development programs to equip the current workforce with necessary digital skills, and this can include training in AI, machine learning, data analytics, and many more technologies. They could collaborate with educational institutions such as FUTA to update curricula and introduce programs that align with the skills needed for the digital job market. 3, indeed, the development and integration of AI, machine learning, deep learning, and biometric systems have the potential to significantly enhance various aspects of economic activities. Intelligent systems can automate routines and repetitive tasks, leading to increased efficiency and productivity. 4, AI, ML, and biometrics can play a crucial role in alleviating security challenges in the country. By implementing AI-driven surveillance systems with face recognition and object detection capabilities can enhance monitoring in public places. And finally, the application of artificial intelligence, AI, machine learning, and soft computing can extend across various sectors and contributing to the advancement and improvement in agriculture, healthcare, education, industries, and entertainment. Acknowledgements. My Vice Chancellor, sir, I thank you once again for this noble privilege. My success stories of today is a result of contributions of several distinguished personalities ordained by Almighty God as my destiny helper. First and foremost, I return all honor and adoration to Almighty God, the Ancients of the day, and the I am that I am. Without him, I'm nothing. I express my gratitude to my parents, Chief Olabode, the Lubokun of Olabode Kingdom, and Chief Mrs. Clementina Olabode, the Yalaje of Olabode Kingdom, Iditutu local government area. I also appreciate your undoubted care and love, especially during my training period as a young boy. You made great impact in me that I cannot only express in words. Your counsel I have adhered to over the years. May you continue to enjoy the fruit of your labor in the almighty name of our Lord Jesus Christ. I appreciate my uncles, my aunties, Mrs. Melody, Umia Kimoju, Laemi, Wemimo, and many others. I thank my uncles and their wives whom I live with and mentored me at my tender age, which includes Uncle Adebayo Olabode, and also late Professor Olushola Fakwetu, who was my parent here in Futa. Others of my uncles include Tayo, Dujoye, and many others. Your labor of love will not be in vain in Jesus' name. I sincerely thank Chief and Chief Mrs. Obawaya, my Christian fathers and mother. Thanks for their prayer and counsel from time to time. I appreciate the prayers and support of my spiritual fathers and mother, especially Prophet and Evangelist Olabode and his wife, Evangelist Olajimoke of Prayer Center Church of God, and Prophet and Evangelist Muhyiddin Kasali of Hour of Mercy. I also appreciate Prophetess Adenike Olabode JP and Prophetess Awotola, the Iyabeji of Eye of God Church. God bless you all. I appreciate all my teachers in primary and secondary school. My profound appreciation also goes to my B.Tech supervisor, late Professor Ademuli, my M.Tech and PhD supervisor, Professor O.C. Akiyoku, for nurturing my academic career to enviable heights. He was instrumental to my joining FUTA in 1995. I also want to appreciate my mentor, my PhD co-supervisor, uncle, and my friend, Dr. Shola Olofeso of the Central Bank of Nigeria. I also appreciate my second PhD supervisor, Professor Olojimi. I would also like to appreciate others of my PhD master supervisor, Professor B. Victor Agagu and Professor Olushoga Pastor Abaku. Thank you all. My appreciation goes to a number of professors within the university. The list I cannot exhaust. Especially, my appreciation goes to my research collaborators. Also, I have long lists. I also appreciate students that I have ever supervised. I may not be able to exhaust the list. Thank you very much for your cooperation and understanding. My sincere thanks to all the following past vice chancellors since I joined FUTA as a student. This includes late Professor Theodore Ibiu Francis, late Professor Ilibombade, late Professor Ilibombade, then Professor Kolawole, Professor Adeyemi, Professor Adeniyi, Professor Balogun, Professor Fasakin, and the late Professor Daramola, and then Professor Fuakbe. I also thank members of the university management here present today. I am sincerely grateful to the past deans of the School of Sciences since I joined the universities. This includes late Professor Kumuroti, late Professor Adetui, late Professor Pashui, Professor Adedire, Professor Fuakbe, Professor Koriko, who contributed to my growth in FUTA. My profound appreciation goes to the pioneer deans of School of Computing, Professor Adewale, and the current dean, Professor Alishe. I also acknowledge the contribution of all the past and present HOD of the Department of in the departments in School of Computing. We have long lists, but among them includes Professor Falaki, the Emeritus Professor, Professor Alishe, Professor Adewale, and many more. I wish to acknowledge my friends and friends of the university for their support, which includes Dr. Ebiwon Jimi Fumi, I think he's a donor, Chief Tunde Akindeyin, Dr. Yaya, and many more. I thank my siblings and their spouses, which includes Mrs. Dosumundalapo, Olabode Oladele, Dr. Oladiton, Titilayo, Folashade Aremu, Ayola Olabode, for their support and love we have shared over the years. To my cousins and siblings that we grew up together includes Professor Melody Goke, Adego Julola, Tayo Logonjaye, Bola Melody, and many more. Finally, my vice chancellor, my appreciation goes to my family. First, to my beautiful and wonderful wives, includes Professor B.T. Olabode, Bola Titilai Olabode, and Prophetess Adenike Yabo Olabode JP. my adorable and lovely one, my jewel of inestimable value, my confidant, my companion, my friend, my sister, and indeed my unending passion. Thank you for your patience, prayer, and encouragement and understanding at all times. Also, to my lovely kids, includes Toluwalope, Olatubosun, Damilola, Ifeoluwa, Michael, Peter, Joy, and Victor, for being source of joy to me always. Distinguished guests, ladies and gentlemen, I thank you all for listening. God bless you all.
Another round of applause for our inaugural lecturer. Thank you very much. You may please be seated. Distinguished ladies and gentlemen, you will agree with me that those who are illiterates in matters of machine learning have been educated by our lecturer. Thank you very much, Professor Olabode, Olatubosun. It is customary for us to recognize everyone present here today. So we thank you all for coming. But please permit me to recognize some special people in our midst who have come to honor us today. I want to start with our own Professor Olatude Arayela, is a former Deputy Vice Chancellor Academic. Thank you, Prof, sir, for coming. We also have the former acting university librarian, Dr. Mrs. Adenike Abiolu. Mommy, thank you for coming. In our midst today, we have Mr. Kehinde Oladeji, the former bursar of Olusegun Agagu University of Science and Technology. Thank you very much, Mr. Oladeji. Professor Olubode Kolade Koriko, a former member of council. Thank you very much, Prof. You are always here with us. Today, we also have Professor Fashion Rambaku, is also a former member of council. He's still a serving member of council, so he's my employer. Professor Sunday Adewale, former chairman, Committee of Deans, FUTA. Thank you very much. He came in this afternoon to dress the inaugural lecturer. Thank you for all you do, sir. Just coming in is the former Vice Chancellor of Redeemers University, our own director of WASCA, Professor Adeyewa. Thank you very much. He's been very busy since morning. That's why he's coming in now. Ordinarily, we meet him here. Thank you for always being with us, sir. We have Dr. Ebenezer Olajuyigbe, is the director of ICT, UNIMED. Thank you very much, sir. And is the husband of our own Professor Mrs. Olajuyigbe, the director of Central Research Laboratories. She's also here. Professor Oluwole Charles Akiyoku, the supervisor of the inaugural lecturer. Thank you, sir. And a big congratulations to you, sir. Mrs. Dolapo Dosumo, the former director, NAO, I think that's National, I forgot. Mrs. Mrs. Dolapo Dosumo. Thank you, ma. We can't find, okay. Dr. Mrs. Titilayo Oladiton. Thank you, madam. Dr. Mrs. Oladiton for coming. Dr. Emo Odim from Redeemers University, Ede. Thank you very much for being here. Today we also have Chief Mrs. Clementina Olabode. Chief Mrs. Clementina Olabode. Thank you, Mama, for joining us today. Pastor Mrs. Ogunsheye. Pastor C&S Ayoniu. Thank you, ma. Mrs. Bosede Melody, thank you for joining us. Olori Toyin Fayoshe, Olori Ulogun in Ekiti, thank you very much. Ido Ekiti, thank you very much. We also have Olori of Igbole Ekiti. Please pardon me if I miss it. We have Senior Apostle Samuel Olafusi, Ido Ekiti, also from Ido Ekiti. Thank you very much, sir. We have Dr. Mary Odogun, the coordinator, Pediatric Department, Federal Teaching Hospital, Ido Ekiti. Thank you, ma. Dr. F.M. Adeniyi, Federal Teaching Hospital, also from Ido Ekiti. We have members of the C&S, Ayonio, Ido Ekiti. If you are here, please just wave your hand so that we'll recognize you. Thank you very much. We also have the members of staff, Federal Teaching Hospital, Ido Ekiti. If you are here from Federal Teaching Hospital, Ido Ekiti, also let's see your hand, please. Thank you very much. We appreciate you. In our midst today, we have His Royal Majesty, Oba Akinwumi Obe, Olulero of Okelero. Kábíyèsí ẹ má bínú o. Adé apẹ́ lórí, bàtà apẹ́ lẹ́sẹ̀. Èrùkẹ̀rẹ̀ apẹ́ lọ́wọ́, àṣẹ apẹ́ lẹ́nu. Kábíyèsí, thank you very much for coming. We also have in our midst today the children of the inaugural lecturer. Children of the inaugural lecturer, we recognize you. Thank you very much. The inaugural lecturer has introduced his wives to us. We recognize you, Mrs. Adekemi Olabode, Professor Mrs. Helen Titi Olabode. Thank you very much for supporting the inaugural lecturer. Members, we recognize the members of the family of the inaugural lecturer. We thank you for coming. Friends also of the inaugural lecturer, we recognize you all, the academic and professional colleagues. We also recognize the gentlemen of the press. And we recognize the most important group of people here present today. Great Futarians, you are the most important and you are the best. Thank you.
Thank you very much. Having come to the end of this inaugural lecture, let us all rise and remain standing for FUTA and national anthems.
Serve
Let us all still remain standing for the academic possession of the Vice Chancellor in a reverse order. The former Vice Chancellor of Redeemers University, Ede, Professor Sakios Adeyewa, you're welcome. And former member of council, Professor Onyekwelu, you are welcome. For your entertainment, students